growth phase. Growth phase is the second phase of the formation of spermatids. The growth phase is characterized by the formation of primary spermatocyte. Note down the points. This phase is characterized by the formation of primary spermatocytes. Formation of primary spermatocyte. When spermatocyte is formed, it is also termed as spermatocytogenesis. That means formation of spermatocyte. In this phase, the spermatogonia, other than the spermatogonial stem cells, increase in size by accumulation of the nutritive material in cytoplasm and replication of DNA. What I told? Here in this phase, the spermatogonia which spermatogonia other than the SSCs, spermatogonial stem cells. Other than the spermatogonial stem cells increase in size becomes spermatogonia become almost twice, almost double or almost twice by collection and storing, accumulation of nutritive materials in cytoplasm and replication of DNA. It accumulates these nutritive materials from the surrounding Sertoli cells. The spermatogonia, how they increase? They accumulate the nutritive materials in the cytoplasm. Also the DNA are replicated. Replication of DNA occurs. This nutritive fluid, materials is absorbed from the surrounding Sertoli cells. Sertoli cells or knot cells. We know the Sertoli cells, they nourishes the developing germ cells. These nutritive materials is absorbed from the surrounding Sertoli cells. Hope you have noted down. Next. Now these enlarged spermatogonia are called primary spermatocytes. Now these enlarged spermatogonia are called primary spermatocytes. Here what happens? These primary spermatocytes prepare themselves to enter the meiosis or maturation division. These primary spermatocytes prepare themselves to enter the meiosis, that is the maturation division. To enter the meiosis, maturation division. Now, enlarged spermatogonia are called primary spermatocytes. The point to be remembered that here there is no cell division. Here no cell division occurs. No cell division occurs. Only the growth of cells occurs. Growth of increase in size. And another point most important is the growth phase of the spermatogenesis is much shorter duration. The growth phase of spermatogenesis is of much shorter duration. A shorter duration means comparison is done much shorter duration than that of oogenesis, means then the growth phase of oogenesis duration, then that of oogenesis. For your information, the growth phase is a much longer period, much longer duration in oogenesis, which starts from embryonic stage and ends up in the reproductive phase, the reproductive period, reproductive age. It lasts for a very long period, that is from embryonic age to reproductive age. Now let us just have an idea how it happens in a diagrammatic representation. As in multiplication phase, it is started from PGC, primordial germ cell, which gives rise to spermatogonial stem cells, or simply we can say the intermediate spermatogonia or simply spermatogonia. So, one primordial germ cell gives rise 4 spermatogonia by 3 mitotic division. These are the spermatogonia. When a diploid, these are diploid, primordial germ cell is diploid, spermatogonia are also diploid. These spermatogonial stem cells are also diploid. In the growth phase, here is the growth phase starts. Thus, each spermatogonium which enters, means those spermatogonia enters into the growth phase, they enlarge in size, almost becomes double or twice of the spermatogonia. But there is no change in the chromosome number. There is no cell division, no change in chromosome number. It becomes almost double. This enlarged spermatogonium, this is also spermatogonium. This is enlarged spermatogonium is called primary spermatocyte. This is only, here it grows, and this is growth phase. The multiplication phase followed by growth phase. Multiplication phase is followed by growth phase.